يلا يلا بسم الله توكلنا على الله. So today we are going to talk about chemical kinetics. Okay, so briefly chemical kinetics define how the reaction proceed, how fast the reaction proceed. It's an important to understand how you follow the reaction, also the mechanism, give you a shade light, give you information about the mechanism of the reaction. But mainly we mean kinetics. What does it mean? Kinetics is the speed, something divided by changing in time, like our speed with our cars, change in distance divided by change in time, so we'll get the speed. The same way we are going to the chemical kinetics, so we are going to measure the kinetics. It means how far, how does the reaction proceed. So let's go first for some definition like chemical kinetics. Here what we have here, so we have, first of all, let's say this is the kinetics. Let's make a differentiation between kinetics and thermodynamics. Kinetics show how fast the chemical reaction proceed, the speed, how fast. Also, as I mentioned, and I will mention next slides, it's the mechanism. But for the thermodynamics, it tells you, does a reaction take place or not, whether it will take place in this condition, under this condition or not. Only it will not tell you anything about the speed. So the reaction kinetics equals to the reaction speed, so it's a measure of the change in concentration with time. If you remember, I told you it's changing something during this period of time. As a speed of a car, you change your distance, so you have delta d distance divided by delta t. So here is no distance. So what we are going to do, we are going to talk about change in concentration divided by this time consumed during this change. خلاص, that's just a definition. Let's go to the important factors which affect the rate of reaction. So when you are moving, when you are traveling with your car, sometimes you need to be fast, sometimes you be slow. Okay, so there is some factors affect your speed in the street. Now, what are factors affecting the speed in our chemical reaction? We have, first of all, the reactant concentration. We have reactant A and B. For example, if you have A plus B, will give C plus D. So the concentration of the reactants, always we are talking about reactants, will affect your concentration, will affect your kinetics. Whether you increase or decrease concentration, it will move faster or slower. This will be in details later, okay? Also the temperature, the second point is the temperature. The temperature means if you increase your temperature, whether the reaction proceeds faster. So later we will go for the collision theory, which describe exactly how we control the reaction by the effect of reactant concentration and temperature. Also the presence of a catalyst. We know the catalyst is a substance enter the reaction and come out without any changement for itself, but it find another pathway with a lower activation energy. What does it mean in general? It speeds up the reaction. It speeds up the chemical reaction. بتديك تفاعل أسرع when you give a catalyst. Okay, the surface area. Look at me. The surface area, when you are going to make a chemical reaction, always chemical reaction will happen at the surface of your reactant. Imagine this is a reactant. So what you imagine, if you grind it or break it apart, it will be like that. So more surface will be exposed to each other, so more chemical reaction will be expected. Also, the last one is for gases. The activity or the power of the gas is measured by the pressure. So the pressure will affect the kinetics, the chemical speed of or reaction speed of gaseous reactants or products. This is first. So we have the definition of kinetics. What is the difference between kinetics and thermodynamics, and what are important factors which affects rate of reaction? Okay. Herein, it's repeated. Study the rate. What are kinetics? Study the rate at which the chemical reaction occurs. Thank you very much. Beside information about the speed at which reaction occurs, kinetics also shed lights. Give you a shed light on the reaction mechanism. Show exactly how reaction occurs. You know what does it mean? Mechanism. How the reaction proceeds. How? So it gives you shed light. It gives you information about that, along with your speed, your timing, your changing concentration during this chemical reaction. Okay. Now, for the outline of your work, your kinetics, so we have the definition of the reaction rate, how we measure the rate. So we are going to discuss this point, something called rate law and integrated rate law. Keep it aside. Keep it aside. Why? مش keep it aside, we'll leave it. No, no, no. It needs more clarification. I will clarify now in another part, okay? So, rate law, how the rate depends on the amount of reactants, like depend on the concentration of reactants, how much the rate will depend on integrated rate law. So this is a rate law, and this is a rate law. Rate law divided into two parts. Differential rate law, it's not here, differential and integrated. So the integrated is a part of the rate law. So integrated rate law show how to calculate the amount left after time. So I will start my reaction after, for example, 20 seconds. How much remaining at this given time? This is what its integrated rate laws looking for. The half-life, how long it takes to react 50 of the reactants, 50%. What does it mean? If you have, for example, 6 moles of your reactants, so the time to consume half of them, 50%, so the remaining will be 3 moles. So the time used to consume half the previous or كلمة initial ممكن تعمل doubt لكن خليها how is the time needed to consume half the present quantity. طيب التايم ده سميناه T half. So what about this one? If this also transfer to 1.5 mole, so you consumed half also, so you have another T half, and etc. If you have something like that, moles, it will be also half. Arrhenius equation. Arrhenius equation always related to the how the rate constant depend on the temperature. You know that we discussed that temperature is one of the factors affecting the rate. So we will relate Arrhenius equation and the temperature with something we call it delta H naught, which is change in enthalpy. And finally, the mechanism, the link between the rate and the rate of the molecules or molecular rate and the molecular scale process. So the rate and what's going on inside, how it proceeds during this period of time. So these are points covering the kinetics. So let's start for the reaction rate. So to start with the reaction rate, I want to say something. Please, I will shift here. Can you see the PowerPoint clearly? I think yes. Okay, I will discuss that here in details. Now, I want to measure the kinetics. I will stay here for a little bit time. So I have A plus B gives C plus D. Now, I need to measure the rate of reaction. Okay, so imagine, خلاص, take it aside. Let's imagine initially at time 0, I have, for example, 6 moles, 0 mole, 0 mole. Now, after time t, t1, this will be 5, this will be 5, this will be 1 and 1. After time 2, another time. We are measuring time. At this time, I will measure the concentration. طبعا الخمسة دي or 5 or 6, this is, imagine it's a unit quantity, a concentration, as you want. 5 molar, 5 moles, etc. It gives you the quantity. Oh, the concentration gives you the quantity. So it will be 4, 4, 2, 2. What can you see? I can see that the concentration or the amount of reactant decreasing by time. The concentration or the quantity of products increasing with time. Let's continue. I have T3. Thank you. Of course, we will measure the time and respect the unit, whether it's second or minutes or like that. So this will be, for example, 3, 3, and this will be 3, 3, and etc. Continue. Okay, continue. I don't care about what happened next. I want to discuss what happened here. So we mentioned that the rate of reaction or rate of chemical reaction equals to the change of concentration during a period of time. Tell me, changing of concentration of products or reactants. This is the main point we are looking for. We said that rate of reaction equals to, look at this one, change means delta. Concentration, 2 half square brackets. Concentration, what is inside? What is inside? Okay, so this will be divided by delta T, means the time consumed. So now look at me. Which one I will follow? A, B, C, D? I don't know. You can follow your rate of reaction by any one of them. By any one of them. So let's imagine A and B, I will call them reactants. C and D, products. خلاص يبقى نتكلم على reactants and then products or product reactants. Then we will talk about A, B, C, D. Okay? So let's imagine all of these are reactants and all of these P products. Okay, let's go for products. Let's go for products. I will measure rate of reaction depending on C. So equals to change in concentration of C divided by delta T. So it will equals 2. Yalla. Excuse me. Let's take it between these two times. يلا. اعتبروا T1 means 1 minute, T2 2 minutes, T3 3 minutes. So let's do it. Delta means final concentration minus initial. And excuse me. And delta time, the time consumed during this period of time. So let's see the time. I will have T3 minus T1. So it will be 3 minus 1. So what is the concentration, final concentration? It will be 3. What is the initial? It will be 1. طبعا 0 دي معنى الانيشال, okay? We know that always delta means final minus initial. So what we have here, we have 2 over 2 equals to 1. So what is the unit? What is the unit? Take care. The unit of concentration divided by the unit of time. Imagine, usually the unit of concentration is molar. The unit of time is a second. So I will have a rate of 1 molar per second. طبعا المولر بتساوي ايه؟ mole per liter. You know that. Over S. So this will be mole per LS or mole L minus 1 S minus 1. كلها نفس التعبيرات. So what we have here? So what we have here, look at this one, please. We have a rate and it's automatically due to you are using the products. When you are calculating your rate of reaction, it will be a positive value. واحد, it's a positive. Why? Why it's positive? Because you are telling me that the concentration increasing. So the final concentration will be more than initial. الانيشال اللي هو بدايه التايم اللي انت بتقيسي فيه او اللي انت بتقيس فيه. So it will be 3 minus 1 divided by 3 minus. Thank you very much. Let's do the same, but for something else, like I will change the color for A. For A. So the rate equals to يلا نعملها مباشرة زي ما عملنا، بس خدوا بالكم I'm not missing a point, but I will skip it and back وهقول النقطة دي ايه. دلتا A over delta T. Let's do it. يلا during the same period of time. During the same period of time. I started from 5 and now I am 3 because concentration decrease. Concentration decrease. Thank you. So what we have here, delta means طبعا نعمل الكونسنتريشن زي ما عملت ونعمل اللي احنا عايزينه. هنقول ايه 3 minus 5. 3 minus 5. What is the time? 3 minus 1. 3 minus 1. So what we have here, minus 2 over 2 equals minus 1 molar per second. You cannot have a rate of a negative value. It's a mistake. So this is the point I skipped. So I will be back. What is the solution of this point? When you are calculating your rate of reaction, which is the change in concentration of reactants divided by the time consumed, you have to insert a negative sign initially here. When you insert this initially negative sign, it will cancel this one and make it positive. It means you have to go like that. It means it will be like that. Why? Because the rate is measured by decreasing the concentration, so it will give you a negative, and there is no a rate in negative. ولا مرة you drive your car and you mention that I am moving with a speed of minus blah 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 blah. There is no speed of minus, it's a positive value. So what is the difference? When you are calculating your rate of reaction depending on reactants, you have to insert a negative sign. When you are using the concentration of products to calculate your rate of reaction, no worry, make it directly the delta concentration of products divided by delta concentration of reactants. لأي واحد يعني when you talk about D, talk about D, talk about C, talk about C. But take care. At this moment لحد هذه اللحظة I am using only 1 moles of each. عشان كده بقول مفيش أي مشكلة. Is a number of moles. Change it from 1. I will have another way. We will discuss that next. Don't worry. Step by step. So my dear students, my dear audience, you have to know that the definition of the rate of reaction is change in concentration divided by change in time. This is the first point. So we can say the rate of consuming the reactant, because a negative sign means consuming. The rate of decreasing the concentration of reactants, or the rate of producing, because it's a positive value. It's new thing will be produced. So we have to take care about these points especially. Why? Because you will make mistake if you don't realize that point. So the definition of kinetics, we know that it's the speed of the reaction. How you measure the speed the reaction? You are measuring the rate of reaction. You are measuring of the rate of reaction means the change in the concentration of reactants or products divided by the change in time. If you are using the change in reactant concentration, you have to insert a negative sign before, because it will give you a negative sign. So sign will cancel sign to the speed, or the rate should be a positive. On the other hand, if you are using the products, no worry, do it. I don't care. أيا كانت النتيجة. I don't care. It will give you a positive value. Take care about the unit. Don't worry. It will give you a correct answer. Okay. طيب. Can I continue from my own before going to that part of PDF. So now I will make two things to differentiate. When you are talking about kinetics of a chemical reaction, we will discuss, or normally we discuss two things: rate of reaction and rate low. الاثنين متصلين ببعض، بس ده له طريقة حساب وده له طريقة حساب. So what is the rate of reaction? The rate of reaction is divided into two types, or two parts, sorry. The average rate, where is the pen? The average rate, ماله البن? Rate. في مشكلة في البن تابلت، sorry. What's up? Rate and instantaneous. بسم الله الرحمن الرحيم. Rate. What does it mean? معلش طبعا الخط it's not my hands, البن تابلت. The reaction rate, look at me, divided in two parts. حاجة اسمها average rate وحاجة اسمها instantaneous rate. Look at that one. The average rate اللي احنا عمالين نتكلم عليه من الصبح، اللي هي دلتا concentration على دلتا تي، ده اسمه average rate. امال ايه هو instantaneous rate? Let's go for an example. Now, if you are moving from here to your college, I will take my car. Now I will start driving. I will take a speed increasing. Then I will find a crowdness. I will slow down. Now my speed drop. Now I will start increasing acceleration again. Then I will find a traffic light. I will stop. Zero. Your speed is zero. Now we will start from zero. Go, 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 go. Oh, it's a highway. It's an open way. So I will drive with the limit of speed, for example, 120 kilometers per hour. So you are changing your speed. So the average speed, it will give you the average. The average دي اللي هي نظريه الرادارات اللي على الطريق السريع بيحسبوها ما بين الرادار والرادار. هم حاسبين المسافه، ذكاء اللي هم بتوع الرادارات، مهما السائق بيجري ودخل على الرادار ويهدي سرعته ويجري عشان يهدي قبل الثاني. في بعض الرادارات بتقيس المسافه، هم قايسينها اصلا ما بين الرادارين وعارفين ان السرعه مثلا سي 90 او 60، فهم قاسمين على الزمن المستغرق، فما يعدي من هنا ويعدي من هنا بيحسبوا الزمن المرور مش السرعه، فيلاقوا السرعه الزمن اقل يبقى انت تجري. So the average rate، خلينا نرجع لموضوعنا. This is between brackets. So the average rate is, tell me the distance you covered divided by the time. والله زادت نقصت هيديني المتوسط او المعدل. This is what we are making. The change in concentration divided by time. ايه هو instantaneous rate? Hello, how are you? Now tell me what is your speed at this moment. It's an instantaneous, instant، at اللحظة، في اللحظة، at instant time، هذه اللحظة. What is the rate at this moment? So at this time طبعا احنا بنقول ايه؟ ان هو السبيد divided by برضو دلتا تي، لان هي بتبقى instantaneous، لحظية، فبالتالي هنقولها ازاي؟ For the average rate بيساوي delta concentration over delta T. So what about this one? We will say that R equals D concentration. طبعا concentration بنديله we give a lot of expression. I give it like square brackets, 2 half square brackets. You can say C or something like that. So it will be delta concentration over delta T. What does it mean? What is the difference between delta and delta? Delta with a مثلث is a difference between the final and the initial state with a measurable value. But for D, it's also delta. It's a difference, but it's instantaneous. It's very, very, very infinitesimal change in time. تغير لا يلاحظ بالزمن، يعني هو تغيير في الزمن ولكن لا يلاحظ، بسيط جدا جدا جدا، بنستخدمه في thermodynamics. So they are the same, but if you see that, you mean it will be at this moment. So now we know the average rate and instantaneous rate. Take care. Remember this one, if this record or the next one. So when you have a graph, خلاص, when you have a graph, you will know how to get the average rate from that graph and also the instantaneous rate. Okay, let's go for the rate law. The rate law is divided into two parts: differential rate law and integrated rate law. بصوا معايا, look at me. Both are giving you the rate, سواء rate of reaction or rate law. Each one got its own relation. Thank you very much. But each one depend on what you are looking for. Sometimes I'm looking about only the concentration, so I will use rate law because always you have time here. I want to measure the rate only using the concentration. I will not use the time, so it's always rate law, for example. Especially the differential. Okay, especially the differential. For the integrated, it uses both concentration and time. I don't want to go in deep, but you have to know two parts: kinetics of chemical reaction, measuring the rate, average rate, rate law. How you measure that? By this one or this one? So let's go for the reaction, rate of reaction. So it will give you the average or the instantaneous. The average, يمكن أنا قلتها دي قبل دي. So rate of reaction or rate law. The rate of reaction gives you the average and gives you the instantaneous. And the rate law will give you the differential or the integrated. It depends. It depends on what are given or what is given in the example. ايه المعطيات؟ يعني انا مش هشتغل من دماغي، ما هو ممكن يديني معطيات ما اقدرش احسب الافريج. Okay, fine. Let's continue. طيب, let's go back first. I think running out time, so let's go keep to stand on a point here. For example, we have يلا. The rate of reaction can be determined by monitoring the change in concentration of either reactants as a function of time. هنا قال either reactants or products. يا ده وشرحناه بالتفصيل. As a function of time, يعني during this period of time. So the change in concentration will give you this symbol. So the rate, خلاص كل ده موجود. كل اللي جاي خلصناه قبل التايم يخلص. So the rate of reaction from A to B. أنا عملت A, B to C, D. Whatever, no problem. I have A, it will decompose or change to B. So there are two ways of measuring the rate. خدوا بالكم measuring the rate ده بقى من دماغنا احنا كناس فاهمه دلوقتي، اللي هو الافريج وبعد كده هنخش على الانستنتينيوس. خلينا ماشيين واحده واحده لان suddenly هتلاقي ميكس، بس نكون فاهمين. So the speed at which reacting disappear or the speed at products appear. قلناها وجبنا الارقام 1 2 3 4 5 للبرودكتس، للرياكتنت كانت 6 5 4 disappearing consuming. Okay, for a reversible reaction, as product accumulate, they can begin to turn back into the reactants. So what we will do, look at me please. I will increase that for you maybe. No, خلاص ما بتكبرش. Okay, look at me. If you have a reaction, this reaction could be forward from reactants to products, خلاص. طب في بعض التفاعلات when you produce the product at the sufficient time they will react again sufficient time and concentration. يعني أنا عندي A will go to B, A and B, sorry خليها أوضح, A and B give C and D, A and B give C and D. So the concentration of C and D will increase until a limit they can react with each other and go back. This is reversible reaction. What we are telling here, the reversible reaction, this one. هنا المشكلة هتبقى في مشكلة كبيرة. الله، ده كده البرودكت هي اللي رايحة للرياكتنت، يعني الكونسنتريشن بتاع الرياكتنت هيزيد. المفروض ان هو بيقل، ف it will give you a confliction. So we have to measure when we have to, if you have a reversible reaction، عشان دي من ضمن الأسئلة المهمة جدا. We have to measure your speed early. On the rate will depend only on the amount of reactant present. We want to measure reactant as soon they are mixed. في الوقت اللي انتوا بتضيفوا فيه الرياكتنتس نبدأ نعمل measuring للريت قبل ما اوصل لمرحلة الريفرسبيليتي. ما تديش اي سماحية للريفرسبل لو انت عايز تعمل الريت للريفرسبل. وطبعا الريت له بيحكمه، بيبقى اكثر تعبيرا. Okay, so now we know how to measure for the forward or the direct reaction and the reversible one. Now, a general way، ده اللي انا قلته، خلي بالكم، a general way to measure the rate of reaction in terms of change concentration instantaneous. طبعا هنا انا معترض على ان كلمه instantaneous تيجي مباشره. لا، الانستنتينيوس هي لها علاقه اللي هي دي اللي انا قايل عليها من شويه الانستنتينيوس، ولكن دي هو ممكن صح، هو كاتبها صح، instantaneous دي اللي هي الافريج. So what does this means my dear all؟ مش اعتراض، لا موافقة برضو، بس يعني توضيح الأكثر عشان لازم the one when he is dealing with that one you have to know that we have average and instantaneous. Now you know this is for average، ده المتوسط اللي هو المحسوب. I can measure delta and delta, but if you are using instantaneous rate this form will be limits to this one. Now you know the difference بين قوي اللي أنا قلتها هنا. Here, yes, I told you. Where is it? Where is it? بسم الله الرحمن الرحيم. فين الدلتا؟ أنا مسحت الدلتا. أمسحها، أعملها كده. That one. I mentioned that I have, this is for average. Sorry, this one, and this is delta for instantaneous. So if you have the rate by delta concentration or delta T, you are measuring something called the average rate. لازم كانت تنضاف في الPDF. I have to mention the average rate. But if you are using the instantaneous اللي هي اللحظة, you can go to my voice or my video previously since 10 minutes, and I mentioned it will be your speed at this moment. So at this moment, so the delta will be very infinitesimal time. So it will be limits to D, which is the delta, but it's very short time لدرجة إن الشخص ما يقدرش يحسبه. It's like at this moment when you see D, this small letter. Okay, good. Now let's continue before the time is off. Now, the reaction rate, very good. The reaction rate is the change in concentration of a reactant or products. So when you are using A to B, A is a reactants, B is the product. So it will be delta. Mute your mic, please. Mute your mic. So rate will be change in concentration of A divided by change in time. And you have to insert a negative sign. Don't forget that. So the change in concentration over the period of time. And if you are looking to the products على طول مباشرة, no sign here, it's a positive change in concentration of B over that of time. So because decrease of A will be a negative and we have no negative rate, it should be positive. Is that clear? So now let's go to very important point. I mentioned that previously which is the reaction rates and stoichiometry. What does it mean, stoichiometry? Stoichiometry is the number of moles present. In the last, if you remember well, I told you A plus B gives C and D, and remember that all of them are 1 mole. So what about if you have A, B, B, C, C, D, D? A, B, C, D, small letter, are number of moles. The stoichiometry of the reaction, the number of moles reacting in the balanced equation should be balanced equation. So when you are measuring the rate, you have to divide by the number of moles for each one. ناخدها واحدة واحدة. Now, قبل التايم ما يخلص, let's measure the rate depending on each one. يلا بسم الله الرحمن الرحيم. فاضل 2 minutes. I will finish. A plus B, B gives C, C, and D, D. Now, the rate equals to, R means rate, equals to, I will measure my rate depending on each component. So, I will start with A. It will be, yalla, minus delta A over delta T. You have to divide by A, number of moles. R equals to minus delta B divided by delta T. You have to divide by B. So you have to divide, when you are measuring the rate of reaction and you have A moles, you have to divide by that one. And R, depending on concentration of C, the product, ما فيش minus delta C capital letter على دلتا تي. طبعا هكتبها بطريقه الثانيه اللي هي مكتوبه هناك في السلايدز او في البي دي اف عادي 1 over C. طب ما هي divide by C, number of moles, and R equals to delta D divided by delta T. It should divide by number of moles of D. تخيلوا جميعا R equals R equals R equals R. This means فعلا minus 1 over A delta A or delta T, delta B over delta T, you have to divide by B. This is minus, and delta C over delta T divide by C, 1 over D delta T. This is products increase, and this is reactants decrease. Thank you very much, and we will continue for the next video for the kinetics. This is the first one. Thank you very much.